probably are wondering why an IoT guy is at a Devnexus Java conference. Well, because I am a Java guy too, and I know the organizers is really delighted to be here. But my day job is to do, as an IBM developer advocate, my expertise is IoT and Edge. And so I decided to bring my IoT and Edge topic to you all today here in a Java conference, just to broaden your horizons of what's coming and what's, I think, going to be a hot trend over the next several years. So I'm prepared a talk today. It is about generating sensor data using IoT, sending it up to the cloud, building an AI machine learning model with the data, the time series data that we collect, and then pushing that model back down to the edge. And so that's what I'll talk about today. So hopefully you found yourself in the right place, because you have about 10 seconds to find the exit. It's going to be fun. So I'm from New York, and I talk fast. I have tons of slides, but I would always much prefer to do a live demo. But I like to use slides to do some setup, because I think that's an important way to set the frame and guide us on our journey. So our journey starts with some sensors. And at the end of the 45 minutes or so, I will be doing edge prediction on some data that we collect from the edge here. And the journey we take, well, we've got our sensors. I'll introduce you to those. We'll generate some data, and we'll send it using MQTT up to IBM Cloud, where we will ingest the MQTT data into Watson IoT platform. We'll then do some real-time analytics as the data is arriving. We'll push that over to Node-RED, a visual programming technique, event-driven. We'll see the data arriving in Node-RED. We'll build some dashboards and some charts. We'll use that to write our data to a Cloudant time series database. And then we'll be able to read the data back into both the chart here in Node-RED, but then also launch ourselves an instance of Watson Studio, which is IBM's data science platform. And it's our portal for data science exploration. We'll open up a Jupyter notebook. We'll import a model, or we'll import a notebook that uses Spark and some machine learning statistics algorithms to generate a model. And then we'll train on the data we collect from our edge device. And then once we've got ourselves a linear regression model, we'll push that back down to the edge. And at the end, if I hold my finger correctly on the sensor, we should start to see some of the prediction model. Okay, so that's our little journey, and I think it's all going to work online. So wish me luck from the demo gods. I lit some candles earlier. So I like to do this all no slides and live code, because if you are interested, you can do this again yourself. I make it available in my Git repository. I share my workshops and tutorials up in Git, and then I also publish them over in my developer.ibm.com. And then we've got a landing page for IoT and Edge, so find it there. But if you're interested in visiting developer.ibm.com, you'll find topic areas including Java and microprofile and many other technologies available in developer.ibm.com. So let's do this as well, let me just introduce you to the thing too. So the thing I have is a ST Microelectronics STM32MP1. It's what's interesting about this particular device. If you've ever built with ST Microelectronics microcontrollers, well, you're programming typically in C, and you're using Arduino libraries, and you're writing C, C++, and you're flashing to the board. It's a microcontroller. What's interesting about this particular board, it's a microprocessor. So it runs Linux. And because it runs Linux, I can actually do some interesting things with it. I can put additional sensors on it. So here I added an environmental sensor board so I can get temperature, humidity, vibration, accelerometer, gyroscope. And so I'm going to be able to use OpenST Linux running on the, it's actually, if those of you are familiar with embedded Linux, it's an Octo-based open embedded distribution, and they've essentially given me, as a Linux guy, the ability to run Node-RED at the edge. So we're going to run Node-RED at the edge, and we're going to collect some data. Let's see if we can do that. Let's go see. So just to prove that, so I've actually SSH'd into it. And, oh, I didn't SSH into it. So let's go SSH to root at. Okay, let's go grab our. We want to go to 1093, 675. Cool. And I can, so now I'm SSH into my board, and I've got some libraries here. Let's go run this one. And now we see that we've got a bunch of data from our sensor. So that was just running on the board itself, just querying using Python, a set of proc directories, and I'm getting accelerometer, temperature, humidity, and gyroscope data. And I wrote another program. So here it is, Node-RED running on the edge. So I'm going to go and read all of those files. Let's jump over to our debug. And if you notice here, we've got one, and every 10 seconds or so, I'm going to send this up to the cloud. So here's my edge gateway sending data from, oh, if those of you who have not seen Node-RED before, I was actually going to do an intro a little bit later, but since I'm here, it's a Node-RED is an open source project founded in 2013. It runs on top of Node, and so it's a local Node.js web server running on my edge device here, so Linux in this particular case. I can use event-driven techniques. I've got a palette of nodes on my left. I've got a canvas, which we call a flow. I've got a debug over on the right side, and I wire together the nodes in interesting ways. In this particular case, let's go scroll to the top. So every 5 seconds, I inject a start, and I go read a bunch of proc variables, and then I put it all together into a JSON object, and I use from my IoT, my palette here, I'm going to use a node to send the data up to IoT platform. And we're going to use MQTT to send the data up to this particular IBM Cloud instance, which I've configured with a device type, et cetera. I'll show you that in a moment. And so now we know we're sending our data up to the cloud every 5 seconds. All right, so how did I do that? Let's go see, let's follow the journey from my device. Now I'm generating device data, and I'm sending it someplace. Let's go find out where I'm sending it. I'm sending it up to the cloud. So to give you, so we've kind of passed our little MQTT story, and that's ST Linux, and there's my sensor data, and there's Node-RED. And what's kind of fun about Node-RED is it can run local on my laptop, it can run in the cloud, it also can run on devices. So it's not just for embedded systems. And there's the data. So now we're sending our data up to MQTT. MQTT, anyone familiar with MQTT? Yeah, a few people. So when devices talk to each other and talk to the cloud, you want to manage a protocol between them. You can open up a WebSocket and try to negotiate, your own, but it's much easier if you use a protocol that's pretty well defined. 20 years old now. Was originally designed by an IBMer, but now an Oasis ISO standard. It is widely used in the IoT community to send data from the thing to the cloud to other things. And it's now there's not the only protocol in this space, but probably the leading one.
So a quick question about MQTT. So the pattern I've seen is something like a LoRaWAN gateway, but MQTT is meant as a high latency protocol. But LoRaWAN, you're basically using LoRa to transmit the data in high latency anyways. So the MQTT is going to come from your gateway, which already has a reliable internet connection. So what's its role?
What's its role here? So when it was designed 20 years ago, I'll repeat the question. So the question was, in a LoRa network, which is already high latency already, why would I need, or in a better network, why do I need a high latency protocol that's going to subscribe pub sub type of techniques? Now remember, when MQTT was designed in 1998, it was for oil rigs out in the middle of the North Sea. They were sending data over satellite communications and then back down. So pretty high latency types of things. And so you had to keep your packets very small. And your packets, because there was not a lot of header here. In the MQTT protocol, headers are pretty tight. We're not sending giant metadata about it. And so that's why it caught on for devices that energy, matter, and high latency was a problem. So that's sort of why it's become popular. Even in a world today when 5G, everything is fast, and it's still going to be pretty, I think, important. Okay, so that's MQTT. And so now we're going to jump up to IBM Cloud. And let's just jump there and show you that. So I jumped up to IBM Cloud, and I logged in. I went over to my catalog. So the IBM Cloud's got a whole variety of services in it, more than I can ever describe to you in a single day. But one of them is a set of starter kits that lets you build and deploy, Java with Spring and Java with microprofile, and here's a Node. We've got Node Express and Python Flask, and this particular one is a Node-RED web starter app. And I said, yes, that's what I want. So I created an instance of that. And I also wanted an instance of the IoT platform. So you kind of create yourself, in my particular login, an instance of a service. And then I bind them together with API keys and credentials. And now I have a Node-RED plus an IoT thing. Okay? And now I can program using a variety of drag-drop techniques. So when I launched that IoT platform instance, I get myself a login here. I'm going to show you that. So once here, since I've got my thing is now called the ST Micro Discovery Kit. So that's what it's called. And when I created an instance of that, I have now a Cloudant database for my data, and I have a Node-RED instance, an IoT instance here as well, and I can go open those up. And so there it is. We see it's running. I'm going to jump over that and just go here for a second. So now I can hit the launch button jump over to the IoT service instance, and I'm not logged in anymore. Let's go launch. Let's go see if it opens up here for me. Here it comes. There we go. Now we see one device is connected. I can make that a little bit bigger for you. Control plus. And let's go drill into our device. It's hanging off the podium, and as long as it doesn't unplug, we can see that it is connected, and we're sending some data. So here I'm sending my credentials and my authorization token, and I'm sending some data. It's got temperature, humidity, accelerometer. So cool. So now I know my device is sending MQTT packets over Wi-Fi to the IBM Cloud, and every 5 seconds or so, it's arriving. Where did it scroll to? a few seconds ago, I got XYZ, accelerometer, gyroscope, temperature, humidity. That's all interesting. I can now see my data in the cloud. Right? Still not doing anything with it. It's just real-time data. I see it arriving. Let's go do something interesting with that because ultimately we want to look for insights. And right now, all I've got are numbers. So my next little part of the journey here is to do some real-time analytics. So let's go do that. And I'll skip forward in my deck because all of this is the things I just showed you. Here we go. There we go. We hit the launch button, and there we see our data. I did create a device and a device type, and I gave it some secret passwords with a credential. So now we see it connected. There's my data. There's arriving. But now we're going to jump over to Node-RED. Because remember, when I created my app, see it's running here, and I can visit the app URL. Let's go log in there. Actually, I did that already here. Oops. Let's go close that. So you'll notice, so let me make that bigger for you all too. Control plus. Now, what am I doing here? So let's go take a look. So in the simplest case, I'm receiving data from the blue node. It's the IoT instance node. I'm getting, let's go jump over and just look at the current flow. Every 5 seconds, I should be getting some data. Let's go take a look here. Come on, baby. Might not have that node particular one configured. So now I'm receiving the data there, and I want to extract out from the message. I'm sending a JSON object. I marshaled it into an MQTT packet, and I'm sending a stringified instance, which I then decode in the blue node, and I'm getting an object called D, and within D I have temperature, humidity, accelerometer, for which I want to put on a chart. So I want to go and grab each one of those, and that's what the yellow nodes do. I just grab a particular value from my JSON object, and I'm going to pass it along to a chart called temperature, a chart called humidity, and some accelerometer and gyroscope. And when I go over to launch my dashboard, it looks like this. So, let's give that a shake and not unplug it. Hopefully we see some data moving up and down. Every 5 seconds at least at worth. All right, so now we know that the data is for real and it's arriving. And so I can actually put my finger on the humidity and temperature. I'll hold my finger there for a couple of seconds, and we can hopefully start to see the temperature start to rise, because now we can at least, we've got data, it's in the cloud, we've got a visualization of it, but we're still not at insights yet. We're just looking at real-time analytics as it's arriving, and it's hopefully getting hotter, and yep, so maybe I'm 30 degrees today. Okay, so that's cool. We're still not at the point where we're doing any analytics. We're getting there. How am I doing for time? Not too bad. Let's keep going on a little journey, because the next thing we want to do is store that data in a time series database, because any data scientist wants to manipulate a time series database and look for, in our case, anomalies in our data set. So I jumped over, before I take you to how I write to it, let's remember in my application, one of the things that was also connected to it was a Cloudant database. Right, and so now the Cloudant database, has actually an alias to it. And let's go and do manage. And I should be able to launch our Cloudant data. So anyone familiar with Cloudant? It's an open source database. Oh, let's not go there. Happens to be running over here. So I hit the button that said launch Cloudant, and it got me here. Again, a really small font. Sorry about that. And you'll notice I've got a number of databases. I've given this talk around the world. In this particular case, in the middle here, we have a Devnexus. We've got 0 bytes and 0 documents. So it's time for us to go write some data to the Devnexus database. All right, and so Cloudant, if you wanted to drill down into it, let's just look at Boston for a moment. And so Boston, when I was there a couple of months ago, I was writing humidity, temperature, and time. And so let's go and create a new database for Devnexus. So let's jump over to our store sensor data reading. So here we have our data is arriving. We've got a function node, which a little bit of JavaScript. And we want to, we only care in my little model about temperature and humidity. We'll do a linear regression on temperature and humidity. So we're going to throw away the accelerometer data. And we only want to store in our time series database temperature, humidity, and time. So let's go generate a little record for that. And let's go write it to a database called Devnexus, which I have 0 bytes in. So let's go deploy that. And so now, as our data is arriving, we should start to store some records over in Cloudant. I'm going to hit the refresh button here. And here we see we have 0 records. Let's hit refresh. And now I've got 3 records. Cool. Now if I drill in, look at it, I've got temperature and humidity. And so now we are storing our data from my board in a Cloudant database somewhere in Dallas, maybe. Somewhere in the cloud, I don't really care. It's a time series database. What do we want to do with that? Because once we're here, let's just jump forward in my deck so that you all, because I keep going back to, have you noticed I keep going back to this slide? Just to give you reference to where we are in our little journey. And we've seen the data on our dashboard. Now we've written it to our Cloudant database. And our next step is Watson Studio. So let's just jump forward. I showed you all of these things. I drew a wire, hit deploy, looked over in Cloudant, drilled down. There's our data. Cool. So now we're going to Watson Studio. So Watson Studio, and this is so much more fun live than slides. So Watson Studio is IBM's data science portal. Most of this is open source tools, right? It's Spark and Jupyter notebooks, and within the Jupyter notebook, you can run Java or Scala and R and Python. And if you've done anything with data science, the data scientists are not real programmers. They just use a debugger. And a debugger is essentially a Jupyter notebook, and they go sell step 1, step 2. Oh, it's an error. Let me rewrite that because they're not very good programmers. They generally only care about the math. And so the data scientists will use a Jupyter notebook in the cloud. So much easier than putting the whole tool chain on your laptop. And that's what we did with Watson Studio. Let's go and show you that. So when you get to Watson Studio, oh, by the way, you have to go to the catalog. And if you jump down into the AI category, let's hit refresh. Oops, I searched on debug. So here, there's an instance of Watson Studio, which I've already created for myself. And this becomes my little reference. And I hit the create button, and I get myself a Watson Studio instance over here on this tab. And what I want to do at this point is create a project, because I'm going to put my data science, my instance of a Jupyter notebook in that particular project. And that's what I did. I scrolled down. And I scroll. So here's one. I have one called IoT Sensor Analytics at the Edge. So let's go drill into that. And I've got an asset. It's a Jupyter notebook. And here it is running Python with Spark. It's got one executor. So in the free tier, did I mention that IBM's got a free tier? So you can join the IBM Cloud without ever taking your credit card out and start to play with a whole variety of our machine learning, our IoT products, our those web starters, which I mentioned. And in this particular case, in the free tier, I get one executor and a Spark instance with Python. Now, if you're doing any real big data science with lots, millions of rows of records, get yourself a bigger Spark executor, take out your credit card. Free tier, pretty easy, kind of get yourself started with data science, whatever, without ever spending any money. So I opened up my Jupyter notebook. Let's go do that. Oh, maybe I have to click into it. And let's go take a look here. All right, so what do we do? We're going to load some libraries, and I'll step you through this. And we want to do a Python Spark session. Everyone look away, because here are my credentials to that. Remember where I was storing the data? And so in this particular case, I had a training data set called training. And so that's cell number 6. And then I read it into, let's go and see if I've got it open here. I read it into my array here without errors. Let's throw in errors this morning. Oh, bummer. All right, so I'll walk you through what it does. So what I'm going to do is I'm going to read my records, and I want to do a linear regression. So I import a number of Spark ML libraries to do linear regression and a logistic regression. And I've got temperature, humidity are the two features that I care about. And I build a set of coefficients. It goes off and does the math for me because I'm an IoT guy and I try not to do statistics, but they keep dragging me back into the statistics world. So at the end of this little math here, I get a coefficient and an intercept, and I can do prediction. Now, remember, every good data scientist has, in addition to their training set, they've got some validation data. So I went and did an accuracy validation. Is my model correct? Humidity, temperature, and normal and not normal. So what I'll do next is I'll take the coefficients and I'll push them back down to the edge. So I built myself a little portal up on the cloud side, and I can go type in what the model intercept and what I learned from my logistic regression, and I can hit a submit. When I do that, in this case, instead of receiving the data, so I fill in a form, and then I use the output, the IoT out node. I'm going to send an MQTT message down to my device, and I'm going to receive it on this side. Now, my edge device will start to know what to do with the data. So here we have, right, we're listening for the edge data. And I'll just inject it because I don't remember the numbers. So there's a model coefficient, and it's scrolling past me, of course. So now I've got data that I can start to validate. So let's go take a look. Because as the data is arriving, I can start to do predictions. So I'm going to put my finger on the sensor here. It's going to start to warm up, I hope. I'll hold it there for a bit. Sure, yeah, I'll take some questions while I'm getting it hot. What's that? Mm-hmm. So I built a JSON object in the cloud, and so here what I did is in the form, I build an edge model. So here's a JSON, and I'm going to send the model intercept Let me open that for you. The coefficient, because this data is what I just got from my, if I had been able to hit the run button, I got the data here. I got these two numbers. Okay, so I'm pushing. What's that?
It's pretty much static, right? Or the dynamically as the data changes.
I don't have it retraining every time, but I could do that if I wanted to. This one took a training set which I built a couple of weeks ago because I got it hot, then I got it cold, and I had some training of.
How do you dynamically take? Because you're taking it from the form, right? Otherwise, you would dynamically build a message from the database.
So what I could have done here, after I've tested my model, I could have made it an entry point, and I could have pushed it. I could have pushed it down via another entry point. I wanted to show a form. I kind of wanted to show you this form where I put the values in and I did a submit. Okay. And so now when the data arrives down here, let's go take a look. Is it getting hot? Hopefully I've got my finger on the board. All right, so we see the humidity is going up, but the temperature is still hovering about, I have to make it hotter. There, starting to get a little hotter. I don't think my finger was on the temperature. Yeah, see the temperature starting to rise? And so the math here, I'm doing the logistic regression in this function. So what I should start to do, so there's a sigmoid function here, and I'm looking for true. So a logistic trying says there's anomaly or not anomaly. So right now there's no anomaly being discovered until my sensor starts to get hot. And I think I'm getting hot.
Is this model is running on the device?
The model is now running on the device. I've pushed this particular flow, as I'm reading it, should be getting, I'm still getting false. It was fun because I did this up in New Jersey where it was really dry. I could not make my model work because the humidity was too low. But here it should be coming up. I don't want to blow on it too much with all the germs flying in the air. All right, so what's going to happen? So if the model turns out to be true, I'm going to give you an alert, and it's going to look like that. You'll see an alert there, right? I'll just hold my finger for a couple more minutes. So what we were able to do in our little journey here was send the data up to the cloud and then build a model and then redeploy that model back down to the edge to do some edge prediction. Now, why is this important? Well, the edge is, especially with 5G, especially with more powerful, cheaper devices, we're going to be able to move the data. It swings in pendulums here. So now we had swung from client server to the cloud, and now we can swing back. We can build our model in the cloud and then deploy back down to the edge. You would never build a model here. You build the model in Watson Studio or the cloud, and then you deploy your model to your production line, to your facility. And now you can update the model remotely depending on conditions, and then control the device with cloud native techniques to push down new models to your edge devices. Now, maybe I'm looking for vibration, maybe I'm looking for temperature, my machine's running too hot, it's needs to be oiled because I can tell the vibrations are bad, or I've got a set of sensors on my production line that read a variety of data and I now know what's normal or not normal, and I can stop my production before any damage happens to my devices. And so this idea of being able to use the power of the cloud and AI predictions, but not send all the data to the cloud, because especially if you're in a moving vehicle, you don't necessarily want that latency all the way to the cloud and back. You want to be able to do it right at the device. The device is smart enough to read the sensors and do some edge prediction, not edge modeling. So hopefully, I'm not getting hot enough today.
So what is your suggestion? Basically, you send enough data to get the model right and then start using the model?
Say it again.
So what is your suggestion? Basically, sending enough data to the backend to get the model right?
Yes.
And after that, once you have the model, you start using it.
And you can, so the question was, collect enough data, enough training data to build your model in the cloud, and then send it back down to the device for scoring.
What framework is on the device that you interpret that model and find out?
So in this particular case, I'm running a Node server, and I'm running Node-RED, and the actual prediction model. So here, up above, is where I'm reading the sensors, right? And then I calculate this, I'm building a JSON object, and I send the data to the cloud. That was what we saw in the first part, right? We saw the data arriving in the cloud. And then, did it just kick in? You saw it, right? It's hot enough. So then here's the prediction model. So in this particular, this is where the math for logistic regression occurs. And I do a parse float, there's a bunch of in my case, I'm doing math. There's a math regression.
IBM is providing any edge device framework?
Now, I just happen to have a great partnership with STMicro. You could do this on a whole variety of devices. I like this one because it has an LCD. And every once in a while.
So this is mostly MQTT based communication?
Yes, this is MQTT based, right?
Security.
So MQTT uses you can do SSL security, so it's a TCP protocol using SSL, and as part of that, I did set up secure credentials.
So if you look at Microsoft IoT framework, they have this edge frameworks where you can manage basically concentrator kind of thing, multiple IoT device connecting and session management on the cloud side. So does IBM also provides this kind of framework, managing the traffic?
That's what you can manage the traffic here in IoT platform. Let's see, where is that? So here's it arriving, and I can do different things with it. I could build rules in IoT platform. I happen to build my rules over in Node-RED just because it's easier to build in Node-RED.
So, do we have anything for the device management, like loading the software?
Yeah, tons. There's over in our IoT, and this was really about edge prediction, not how we manage devices.
Yeah.
But yes, I can do interesting things now by pushing firmware and registering devices. There's a whole I can go and add a device, and I can add a device type. So there's all sorts of techniques, both with a GUI and with a set of libraries to add thousands of devices. We have a device simulator I can go turn on. All right, so hopefully, so my finger's been on long enough and you can see that it's kicking off alerts. So questions about, why, I told you why I think this is going to be important, because the edge and edge AI models are wildly important now. All right. right. Hopefully you can connect with me on Twitter or LinkedIn. Find my Git repository. My code is available in my Git repo. Be happy to stay, answer questions for about 5 minutes. So you can, in our catalog, I'll take my finger off so I can type. So let's jump back over to our catalog. And if you scroll down to the web and applications space, software. Oh, I'm searching on something here. Here we go. You'll notice that we've got Go and Java Liberty, Java Spring, a LAMP stack, Node.js, Node-RED, Python, right, Swift. So and these are samples. You can you create an instance of, and then you can get a repo and push, program your app local and push to the cloud and restage. A couple of seconds later, it's running in the cloud.
What kind of data or information collections do you see moving to the edge computing?
What type of data do I see moving to edge? So anytime you want to make your device intelligent, right? For a long time, we were just collecting data at the edge and sending it to the cloud and hoping that someone looks at it. Now what you can do is take the data and then build a statistical model, an AI model, and then actually make actionable steps by sending the data closer to the device, right? Lower latency, speed, lower power, time critical data, anything that really needs intermittent connectivity or fast response times. That's where the edge is going to be really important going forward.
Do you guys have connectors for OPC or data storage or for other?
There are. There are connectors. So an HTTP, so WebSocket straight to the IoT platform, MQTT straight to the platform, Kafka available. There are other connectors that we've written for customers. As part of Node-RED, what's fun about Node-RED is you can extend it with additional things in your palette. So if I go to Palette Manager and I go to Install, and I do. Yeah, UA, here we go. So I don't know too much about this node. I can go learn about it. And I could then hit the install button, and my Node-RED instance now, in the palette, I would have an OPC UA node available to me.
So device simulation tool.
So what you would, I've not played with this particular node, but you would, in your palette, you would see these here. So there's an IIO, there's a listener and a read and a write and a response and browse. Yeah. If you've got a programmer logic controller, this is one of the historic protocols that's been generated from the PLC motors and so forth is OPC, and we've got nodes for that too. Yeah, so I to tell you the truth, I skipped over that because my model this morning it ran 2 weeks ago, and I don't know why it's not running today. It crashed out up top, but see, I'll take you down. So what I did is I'll take you through these cells here. I select class 0, which is normal, class 1, which is hot, and I build 2 frames. I select on temperature and humidity, and then here's where I actually do the modeling. So I grab what's important is this logistic regression. I build a pipeline, and I'm going to do a logistic regression, and all the magic happens right here.
What went the input for this? Because your data is only graph the temperature and the how you learn it.
Yeah, so, okay, so let me see if I can logistic. They have a good picture on. There's the math. Basically, you're fitting your data. They don't have a good picture of it here. That's a Wikipedia page. Let me try another one. So the model, once I'm finding the picture. Yeah, it's fitting on it's actually a multivariable. I wish I had a picture for you. I should put a picture in my deck too, just to describe it. Maybe this one. Ah, there we go. So we're doing a multivariable regression, and we're looking for we know what here are some outliers, here's some inliers, and we're trying to do a best fit. And that's why we get an X and Y coordinates. I'll lose everyone. See everyone leaving because it's now math. And so here's a multivariable one, right? So it's actually more of a circle. So there's logistic regression is a statistical technique to group the data sets. I don't know if I've got any other picture. There's a bunch of different algorithms to do this.
So you showed on the Jupyter running the Spark, right? So you
Yep.
can fit that into the node, right? The model also?
Yes, I took the opposite of this, where here I trained. I know. Here I did the training part, and then down here I did the fitting. I actually fit based on that logic. Too small for you to read.
My question is, can we put the model also in the node, like the training part?
Yes, it's more about presenting most people.
Yeah.
The training may not be easy on the node, right? Because the horsepower on that, those boxes are not that much.
Yeah, so remember, where is the Node-RED running? Node-RED is running on a device. You wouldn't necessarily it's a pretty low power. It would take a long time to train a model.
Okay, well, I didn't realize that. I thought this is running on the cloud.
No, the prediction is running here. The model training was running up in the portal. The flow is running local too. I am running a local Node-RED server, yes.
As far as keeping my model current in the cloud, in the actual modeling, do you see the edge device sending all the data up or just the anomalies?
So that's a great question. So how much data should you send to the cloud? I always encourage teams to send enough data to build a model and then turn off the part. You don't necessarily need every 5 seconds of normal. What you would really want to do is when I start to see alerts, to send the alerts to the cloud. The anomalies, yes. Yep. So so the question was, how often should you retrain? And that now let's have a conversation about what you're measuring. And that's when production lines that we work with, industrial customers, to think about, do we want to retrain every day? Do we know what normal is forever? Maybe normal is seasonal. Maybe normal is based on different materials that you're running through your production line. So you would probably talk to your operations team and decide how often you want to retrain. I don't encourage people to retrain every day. Is probably too much. Or every couple of weeks, probably sufficient. I think what happens too is people get reliant on retraining all the time, and then there's big worry about skew, where you start to skew your data. So you have to be careful of that.
Your model is based on normal data. Your model can be unpredictable, and then get how to monitor that.
Yes, there are. So the question is, how do you monitor your model? And the data scientists.
And then your model, your sample data is kind of, you get quite off, and then the model will be off according to
There's a whole science to that, for which deeper than my expertise as an IoT guy.
Training, and it's also self-adjusted on the model for certain way, and because in between your model, if it's not kind of wanted, and it's once it's trained, one of the models stay there, it should be predictable. But when you get you can put model for training either by human or it's automatic. If it's automatic, the model.
So that's why I do encourage teams to retrain their model and actually monitor your model for skew, and just to be careful your data is not being corrupted along the way. Yeah. Mm-hmm. Yep. Cool. Thank you all for coming.